we are still doing the first course and the first chapter. Remember that I divided the first chapter in two parts, part 1A and 1B. 1A we talked about the technology, what is ICE to electric vehicle. In 1B we are getting into nitty gritty, cost, challenges, Indian approaches. But here I thought I need to introduce a little bit, it is still introduction, a bit about batteries. Remember, battery is a capital cost, costs are high, therefore I will need to introduce the batteries and a few parameters about the batteries here. First thing is, batteries, if I buy an expensive battery, it has a limited life. This must get into the head. The battery will last for x number of years, x number of cycles, 3 years, 4 years, 5 years, and it is expensive item. After that you have to replace it. That does not happen in a petrol cars. Fuel tank does not require replacement, battery will require replacement. So you will have to pay heavily, and then you have to worry about that 3 to 5 years down the line you have to replace it, which will again be heavy cost. Of course, one advantage is battery cost is continuously falling. So in 3 years down the line battery will be lower cost, but still you need to understand what is the battery cost in its lifetime and use that to compute cost per kilowatt hour. So the batteries have a finite number of charge-discharge cycles. This number of charge-discharge cycles can be 500, can be 1000, can be 1500, 2000, 3000. There are batteries which can have 5000, 10,000 cycles. But higher the number of cycles, more expensive the batteries are. So typically 1000 to 1500 is commonly used, but you can always get more number of cycles. So that is the first important component. It depends a lot on battery chemistry used. So if I use better chemistry, cost goes up, life goes up. And it is not only about NMC or LFP. I can get LFP battery which are 500 cycle, I can get LFP battery which are 2500 cycles. I can get NMC battery which are 1000 cycles, I can get NMC battery which are even 8000 cycles. Of course, cost will go up. I have to therefore figure out, it is not name of the chemistry, the kind of, it is a manufacturer dependent. The second, how fast I am discharging the battery, and it is called rate of charge. Now how fast I am discharging, you learn it is not in terms of absolute number, how many kilowatt per hour, how what's a kilowatt, kilowatt alone does not matter. What matters is kilowatt versus the size of the battery. What is called C rate, we will define this C rate of the battery. It is used both in rate of charging or discharging. C rate is considered 1 if you charge the battery in 1 hour. So if in 1 hour I fully charge the battery from empty to full, it is 1 C rate. Similarly, C rate is considered 1 when I discharge the battery from full to empty in 1 hour. If I charge in 2 hours, C rate is 0.5. We will discuss this more detail. Very important parameter, cannot do any meaningful work without the C rate. The third parameter, equally important, is temperature. You learn that almost all the batteries that we use today, 25 degrees centigrade is optimum. At 25 degrees centigrade, these batteries behave well. You will get the number of cycles. If you use 15 degree centigrade, the life will reduce. If you use 5 degrees centigrade, life will further reduce. What if you use instead of 25, 35 degrees centigrade? Again the life will reduce. If you use 45, life will further reduce. So, today's batteries, they are designed to be optimum of 25, above 25 it hurts, below 25 it hurts. Now, again depends on the chemistry and the manufacturer, but keep that as a general principle in mind. You like to use it at 25 degrees centigrade. Now, if it is a large battery in a car, you can use a chiller to cool the battery and keep it, or heat the battery, or a heater to heat the battery, and you can keep it at 25 degrees centigrade. But if you are using it in a two-wheeler or a three-wheeler, low cost, you are not going to put that air conditioner or chiller. Remember, the energy for the chiller will also come from the battery. In that case, you have to worry about what happens at 35 degrees centigrade. In India, you have to worry about what happens at 45 degrees centigrade. What happens at 15 degrees centigrade? This is an important question, and it is specifically important for India because our temperatures go up to 45 degrees centigrade in months like May. April, May, June are bad. Then there is another parameter. Are you going to fill the battery and empty the battery? Bad idea. Never empty the battery fully, leave some charge in the bottom. Maybe empty till 95%, leave 5%, 7%. Similarly, never charge the battery fully, charge it to 90%, 95%. This is called depth of charge discharge. Depth of discharge, DOD, depth of discharge used. If you are using between 5% to 90%, you are using only 85% of the battery in a cycle. That is very important. It enhances the life. Then, this is not the only thing, a calendar life. You leave a battery, do not use it for 6 months, battery life has gone down. No cycles performed. Even when no cycles are performed, battery life keeps going down. Does not go down as fast as if you use cycles, but it does go down. So, it has a finite life anyway. Depending on the battery, it may be 5 years, 7 years, 8 years, battery will go 10 years. So, you have to take into account both the calendar life degradation and usage degradation, which comes from the cycle, and these two you have to combine judiciously to understand that. There is another parameter. I am just introducing you these parameters. We will discuss these parameters in great detail later on. This is state of health of the battery. It is a measure of the battery capacity remaining after you have used it for some time. Initially, state of health is 100%. So, sometime you will find it 95%, then 90%, 85%, 80%. What does it mean? Now, it has only 80% of the initial capacity, your capacity has reduced. You could go 100 kilometer in the beginning, now you will be able to go only 85 kilometer. Very problematic, you have to worry about it. Or now you are able to go only 80 kilometer. If you keep it more, it will go down further. So, you will at typically around 80% state of health, you like to replace the battery. That is considered the end of life for usage of that battery in the vehicle. It is not the end of life for battery, you can always use it for fixed application where it does not matter if volume and weight is not that problematic, you can still use it and let it go from 80% to 50%. But for a vehicle, 75% to 80% is end of life, end of life. The value of a battery is not 0, you can reuse the battery, but remember state of health therefore is an important parameter. Typical battery life and charging. Battery life depends on rate of charging. If you charge fast or discharge fast, battery life gets impacted. Ideally, battery should be charged 6 hours is good, 8 hours is even better, 4 hours is acceptable. and that is called slow charging. Fast charge is 1 hour or below, and that impacts the battery life. So, you must keep this in mind. You may want to charge fast because it is convenient, but it impacts the battery life. Even 1 hour impacts the battery life. You want to charge in 30 minutes, it impacts badly. 15 minutes, very badly. Typical battery life, 500 to 2000 charge-discharge cycles. And battery life is always specified in terms of slow charge. So, you can buy a battery with 500 cycles, buy a battery with 2000. Battery with 500 to 1000 cycles are very low cost. If you want 1500 to 200, it is a medium cost. 3000 to 4000 is much higher cost, much higher cost. Batteries with capabilities of fast charge and discharge cost much higher, much higher. In fact, if you start with a battery with 500 to 1000 cycles with fast charge capability of 1 hour, quite a bit of times, the cost may be triple. So, this you must take into account. A question that is not often asked, how many cycles do we need? Depends on how much distance we will drive in our lifetime. Are we going to drive that vehicle for 200,000 cycles? Suppose it depends on the size of the battery, how much range will it provide. Suppose you have a battery with a 600 kilometer range, Tesla car. Suppose you have 800 cycles, you are driving 500,000 kilometer. I do not think you will drive a vehicle for more than 500,000 kilometers. So, for Tesla 1000 cycles is enough, 800 cycles is enough. Occasionally fast charge also can be done. But suppose I take a 100 kilometer range battery, and if I drive only 1000 cycles, then it is only 100,000 cycles. Then I have to replace. Maybe I will need 2000 cycles to 200,000, even that I may, well, most vehicles in India may retire, but otherwise I have to again replace. And fast charge will further reduce the life. If I have a scooter with 50 kilometer range, and if I want charge 15,000 cycles, 1500 cycles, then only 75,000 cycles. So, you must multiply the size of the battery and the number of cycles to figure out. Again a unique problem, because in US and all that you will take a 300 to 600 kilometer, 1000 cycles, 2000, 1500 cycles is enough. In India, you have to replace it. Replacement is not necessarily bad, because you will get lower cost. Now, 600 kilometer range cycle like Tesla car, and you fast charge in 45 minutes, suppose you do full charge, which means suppose you can do 45 minutes full charge, 600 kilometer. In 10 minutes you can charge 150 kilometers. And the battery is so large that you charge for 10 minutes, you can go 150 kilometers. You have reached close to your home, you are slightly running out, 10 minutes you stop, which is not that much, and 150 kilometers more easily, then you can go home and charge. Of course, fast charge is expensive. 600 kilometer is very expensive, kilometer range battery. So, in 600 kilometer, 45 minutes full charge and 10 minutes for 150 kilometer charge is good enough. If you have a 100 kilometer battery and you charge only in 10 minutes, what can you charge? You can't even charge maybe 20 kilometers. That does not give you extra range at all. So, All these are extremely important. I saw in Niti Aayog, one of the company had put up a big charger, they advertise in 10 minutes fast charge to 150 kilometers. They forgot to tell you that was there for only 600 kilometer vehicle, in which such vehicles do not exist in India, and therefore it has never been used. But they advertise big and everybody get confused. And unfortunately, the people who allow the such kind of charges to be put, only adding to confusion. Those officers themselves do not understand. Ministers will go and beat. We have confused the whole thing in India. Only now we are clearing it. Well, this brings us to another home assignment, important, and here I am giving you for the first time a formula for what is called PMT, a effective cost of 1 kilowatt hour of battery. A 2 kilowatt hour battery costs 30,000 rupees. The purchase is made borrowing money at an interest rate of 12%. Battery charge discharge once a day, last 1825 cycle, to be depreciation over this lifetime. Compute an depreciation payment per year. Now, payment per year later computed using a spreadsheet. Here you can compute using this. Number of unit time. Assume 5 rupees per kilowatt hour is electricity charge. Battery depth of discharge is 0.85. Vehicle uses 20 watt hour per kilometer. What is the fuel cost per kilometer? And estimate the PMT, payment that needs to be done for any year. You can do it yearly. Say this, I have taken 1825 is 5 years, 365 into 5. So, you can do yearly payment and you can do for 5 years. So, it will be 1 plus 1 by interest rate, which is 12%. So, 1.12 to the power of n, first year, second year, third year, fourth year, n equal to 1 to 5. You can do that. Do this. This will give you an idea of what is the cost per kilowatt hour for this battery. We will actually discuss this in detail in chapter 3. Remember that we are in part 1 of the course, and in part 1 itself there are 3 chapters. First chapter is introduction. I divided that chapter into 2 parts, 1A and 1B. 1A I looked at the conversion from petrol vehicle to electric vehicle. 1B I am getting into specific aspect of electric vehicles in Indian context. In the first 3 sections, we introduced why there is attraction of electric vehicle in India. Second section, I introduced what are the key challenges in India and introduced the concept of swapping. In the third section, 1B.3, we learnt a little bit about battery, its lifetime, and what factors all it depend on. Now, I will introduce the infrastructure required for electric vehicle to operate in India, and we are going to talk about charging and swapping infrastructure. Remember, I had introduced what is charging, what is swapping. I had asked the question, do we need standardization? And the answer is obvious, some standardization is a must, but not a whole lot of standardization. For example, whether you are charging or swapping, the connector, plug and sockets must be standard. Remember, when we travel outside India, we can encounter different plugs, we get into trouble. So, if you are having different kind of vehicles, if it is not standardized, you will get into problem. It is a simpler of the thing, connectors, plugs and sockets we have to standardize. We of course have to have some maximum voltage and power, maximum voltage, current and power, because above that voltage we cannot then charge. The batteries has to be within that voltage. Lower voltage one can always charge. If you define a 600, 700 voltage as a maximum voltage, you can always make it work at lower voltage. A battery in the vehicle will always require some communication. There will be a communication to the energy supplier, the grid, because that grid has to supply us that much power. I may require so much power for so much time, and they will have to supply me that power. So, I need some communication, say I need so much power, give me that voltage, give me that current, and for so long bill me, how much will it cost, that needs to be standardized. So, billing and communication will have to be standardized. Communication between charger and vehicle, between the charger and the utility provider, and then certain protection, minimum protection needs to be standardized, because we do not want problems to take place when you go to a public charger and charge. Similarly, if I am standardizing the swapping battery, I need maximum weight and size, nothing more than that. I do not need the actual size and weight. For 2-wheeler and 3-wheeler I can define, for other vehicles I can define that maximum weight and size will be so much, because it has to fit into my vehicle size, and it cannot be more than a certain weight, it will hurt. And as energy operator will then give me batteries on lease, will help logistics, stocks and finances, standardization. It will help, otherwise if 5 different vehicles require 5 different kind of batteries, I have to stock so much. Performance, chemistry, etc. need not be standardized, it will keep on improving. It will be a mistake to standardize. Of course, the connector has to be standardized and communication has to be standardized. This is the additional thing that will require. A new business known as energy operator, could be a charging operator, could be a swapping operator. That is what is required for electric vehicle. It is equivalent to a petrol pump, except the charging operator has to be different from the swapping. Swapping is very much like a petrol pump. You go swap in 3 minutes and go. Charging you cannot be like this, because it will take 1 hour, 2 hours, 3 hours, 4 hours. Battery swapping, energy operator sets up battery swapping infrastructure at customer at convenient locations like petrol pumps, enrolls customer. So, you will always swap from my petrol pumps. I have so many petrol pumps, so many charging places, because it will be my battery. I will give you, you return to one of my place and take a new battery. Enrolls customer who will lease EOS swappable battery for their vehicles, will swap a discharged battery with a charged one at any convenient location. There should be 2-3, just like their petrol pumps, there is a BPCL, IOCL, and similarly there should be 2-3 charging operators, so that if I do not like one, I reduce the other one. The energy operator will bulk purchase the battery, cost will go down. It will put bulk charger. See, normally one car, one battery will require one charger. Here I may be serving 20 cars and I will keep on getting 20 such batteries, and I will charge all of them at the same time. And offer from the bulk charger I will charge, keep the battery ready. So, whenever you come I will swap the battery. So, it will enroll and offer charge battery to the subscribers. Customer pays energy usage per kilometer, but remember, energy usage is not just energy cost, but also depreciation and interest costs on the purchase, and this is what I have been trying to compute, and we will do more detailed computation as we go on. Even EOS profit will have to be included. Swappable battery designed so that they cannot be charged anywhere except at BPCL. If I am taking BPCL battery, it can only be charged at BPCL. That protocol is called Lock Smart protocol. We had written that protocol and we have provided that. That is becoming standardization. That will help. What is the charging strategy? I am now moving away from swapping. Ideally, you charge slow, charge in the night, charge at homes, or 2 to 3 hours slow charge in office or parking lots. Not the best that you can charge if you are going somewhere, you have parked, you may even charge in the daytime. If you want to charge slower, it is better. You will typically have an onboard charger. In the vehicle there will be charger, because I will just plug into the grid either at home or at office. That plugging is AC. I will require AC to DC conversion which will charge my battery. So, onboard charger. Now, what kind of onboard charger does a vehicle have? Depends on the vehicle. They will have AC to DC. They will typically have a 15 ampere plug, because in India that is what is available. Our air conditioners, by the way, uses a 15 ampere plug. Our refrigerators uses it, a washing machine uses it. We can get an industrial version of that plug, same plug, and you can draw up to 3 kilowatt, 3.3 kilowatt, and this is good enough for 2-wheelers, 3-wheelers and small 4-wheelers. For larger vehicles, you may want to charge faster, 6 kilowatt to 20 kilowatt, because you have a larger battery, and there is the 3-phase charging. You now need to take 3-phase plugs. These are available in industry. Home we do not use 3-phase charging for anything, but they are used by industry. 3-phase charging, 6 to 20 kilowatt, we can actually do that. For occasional fast charging, long distance trips, vacations, and for buses, they will require regular fast charging. Those will require what is called fast and DC charging. We will get into much more detail of all this as we go on. A question that is often asked: where should be public charger be placed? The biggest mistake that the government again made, say put it at petrol pumps. Petrol pumps are designed to service a vehicle in 3 to 4 minutes. They want petrol vehicles to keep moving. They have no space. Vehicles need to keep moving in and out. Do not have space for keeping a vehicle for 30 minutes, 1 hour, 3 hours. So, petrol pumps charging may be okay if fast charging is possible in 5 minutes, which is not possible. Swapping at petrol pumps is perfectly okay, because that can be under 5 minutes. It is very much like petrol filling. What about slow charging? Office, street parking, shopping, food complex, best place for public charging. Because that is where we keep vehicle for 2, 3, 4 hours. I am giving this lecture, I have my vehicle parked, 2 hours lecture. I could have easily plugged it in. For that, slow public charger is mostly enough. Occasionally I can go to a fast charger, public charger. In fact, all the parking places should move to a slow public charger, and a few places fast chargers where you can go and charge. Or if I have a reserved parking, I should put a slow charging. Overnight I can charge anytime. When I was working with the Power Ministry, Mr. Piyush Goyal as his principal advisor, and I started working on electric vehicle, and we had presented all this great advantage, whatever I am presenting today, in a preliminary form. We had presented 2016-17. A right question was asked to me: where will you get battery from? Of course, I said we will make battery, manufacture battery in India. It will take time, but we will set it up. And we are now setting up the battery manufacturing plants. The next question came: what will the battery material be? Of course, it will require lithium, depending on the kind of battery, lithium, nickel, cobalt, manganese, graphite. What I found out fairly quickly, that we do not have much of these material mined in India. So, what will happen? These material will have to be imported. And promptly Secretary Power told me, so now you are going to import lithium, cobalt, nickel instead of petrol. How does it benefit India? And forever you will be importing. Right question. Problem is, you shouldn't just ask a question, you should say, how will you manage this? You should have a belief that this is the right way to go. Do not stop it, figure out answers. But that question was asked, and we had to fairly quickly figure out the answers.